Hi students, welcome to NADAR'S YouTube channel. Students, in this video you are going to learn about position vector and another topic, that is distance and displacement. Okay students, right. So first we are going to discuss position vector. It is a vector which denotes the position of a particle at any instant of time with respect to some reference frame or coordinate system is called position vector. What is a position vector? It is a vector which denotes the position of a particle at any instant of time, which denote the position of the particle at any instant of time with respect to some reference frame or coordinate system. Okay, we can use the Cartesian coordinate system to explain the position of the particle means. So that vector is called position vector. Okay, so the position vector R of the particle at a point P is given by R vector is equal to xi cap plus yj cap plus zk cap, where x, y and z are the components of the vector R. Okay, here the position of the particle, it is also denoted the point P. Here the position of the particle is represented by the x-axis, y-axis and the z-axis. Okay, so this R vector, this is a R vector. Here it has a position at a point P. Here the position of the vector, it is also given by the R vector is equal to xi cap plus yj cap plus zk cap. Okay students, so what is a position vector? Position vector means it is a vector which denote the position of any particle at any instant of time with respect to some reference frame or Cartesian coordinate system. Okay. Next, distance and displacement. First, distance. Distance is the actual path length travelled by an object in a given interval of time. So what is the distance? Distance is the actual path length travelled by an object in the given interval of time. Okay, so it is a positive scalar quantity. The distance is always positive scalar quantity. In this diagram, I am going to give the explanation for the distance. Here the particle is moved from this point. It is a start from this point, end to this point. Here the actual path of the particle means it is also given in the green color. Okay, the actual length of the path travelled by the particle is called a distance. Okay students, so next one is displacement. The displacement is the difference between the final and the initial position of the object. Okay, it is the difference between the final and the initial position of the object in a given interval of time. It can also be defined as the shortest distance between these two positions of the object. Okay, it is also explained in other words, that is the shortest distance between two positions of the object, and its direction is from the initial to final position of the object. Okay, so it has a direction from the initial to final position of the object. Okay, so it is a vector quantity. The distance is a scalar quantity. The displacement is always vector quantity. Okay, so the displacement means it is the difference between the final and the initial position. In other words, it is the shortest distance between these two positions is called displacement. So here the direction, it is always from the initial position to final position. It is always a start from initial position, end to the final position. Okay friends, here it is a vector quantity. Okay, it has a magnitude and a direction, so this is a vector quantity. The distance is a scalar quantity because it has a magnitude only, it does not have the direction. Okay students, so this is a distance and a displacement. So follow that. Now we are going to discuss displacement vector in Cartesian coordinate system. Displacement vector in Cartesian coordinate system. In terms of position vector, the displacement vector is given as follows. Let us consider a particle moving from a point P, 1, having position vector r1 the R1 is equal to x1 I cap plus y1 j cap plus z1 k cap to a point P2, where its position vector for the point P2, that is R2 vector, is equal to x2 I cap plus y2 j cap plus z2 k cap. Okay students, so already you know what is the meaning for position vector. So here we consider the two position vector, one is R1 vector and another one is R2 vector. The R1 vector is the position vector for the point P1, the R2 vector is the position vector for the point P2. Okay, so here the R1 vector is equal to x1 I cap plus y1 j cap plus z1 k cap. So next for the point P2, the position vector R2 vector is equal to x2 I cap plus y2 j cap plus z2 k cap. So from this point P1 and P2, we are going to calculate the values of the displacement vector. So what is the meaning for displacement? Displacement means it is the difference between the 2 points. It is the difference between the 2 points is called a displacement. So we can write the difference between the two position is given by the del r vector. Okay, that is the del r vector is equal to the difference between the two vector, means that is the difference between the final position and the initial position, that is r2 vector minus r1 vector. Here the R2 vector minus R1 vector means already you know the values of the R2 vector, that is x2 I cap plus y2 j cap plus z2 k cap minus R1. What is the R1? That is x1 I cap plus y1 j cap plus z1 k cap. Okay, so here you are calculating the difference between the two position, means it is give x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So here it is also shown in the diagram. So this is a point P1, this is a point P2. Here the position vector for the point P1, that is a R1 vector, the position vector for the point P2, that is R2 vector. So we need to calculate the displacement, means that is the shortest distance between the 2 points or the difference between the 2 points. Okay, so that is called a displacement. So we are calculating the shortest distance between the 2 points. Okay, from P1 to P2, it has a direction from the P1 to P2. That is R2 vector minus R1 vector. That is the difference between the two position, R2 vector minus R1 vector. It is equal to del r vector. Next, differential calculus. The concept of a function, okay, any physical quantity is represented by function in mathematics. Any physical quantity is represented by a function in a mathematics. Take the example of the temperature. We know that the temperature of the surrounding is changing throughout the day, it increasing till noon and decreasing in the evening. So in a mathematics, you are calculating the temperature, means the temperature is considered as a function because it is changing throughout the day, it is increasing till the noon and decreasing in the evening. So at any time t, the temperature t has a unique value. Mathematically, the variation can be represented by the notation T of t. The temperature at any instant of time is noted by T of t, and it should be called temperature as a function of time. The temperature as a function of time. It implies that if the value of the time t is given, then the function T of t will give the value of the temperature at the time. Okay, if the value of the time t is given, then the function T of t will give the value of the temperature at the time t. Similarly, the position of a bus in motion along the x direction can be represented by x of t, and this is called x as a function of time. Here x denote the x coordinates. Example, consider a function f of x is equal to x square. F of x is equal to x square. Sometime it is also represent y is equal to x square. Here y is called dependent variable. The y is called a dependent variable, and x is called independent variable. Here the y is called a dependent variable. Here the x is called independent variable. It means as x changes, y also changes. The x is changes, y also changes. That is a dependent variable. Okay. Once a physical quantity is represented by a function, one can study the variation of the function over time or over the independent variable on which the quantity depends. Calculus is the branch of the mathematics used to analyze the change of the quantity. Okay. So the calculus is the branch of the mathematics used to analyze the change of any quantity. If a function is represented by y is equal to f of x, y is equal to f of x, then dy divided by dx represent the derivative of y, with respect to x. What is the meaning for dy? Dy means that is the derivative of y with respect to x. What is the meaning for this? If x is changes, y is changes. The change in x is not equal to dx, the change in y is not equal to dy. So, if a function is represented by the y is equal to f of x, then dy divided by dx representing the derivative of y with respect to x. Mathematically, this represents the variation of y with respect to change in x. That only I explained before. Okay, so it is represent the variation of y with respect to change in x. Already I explained to you, when x is changes, y also changes. So mathematically this represents the variation of y with respect to change in x for various continuous values of x. Mathematically, the derivative dy divided by dx is defined as follows. That is, dy divided by dx is equal to limitation del x gives 0. Okay, so there is a changes in the x-axis, that is a del x is give 0 means that is a very low. So here we can write y of x plus dx minus y of x divided by del x. So the limitation del x gives 0, that is del y divided by del x. You are multiply these values. Next step it can be written as yx plus y del x minus yx. So plus yx minus yx cancel that. So y del x divided by del x. So y del x means here it can be changed to, that is del y divided by del x. Okay, so the dy divided by dx represent the limit that has the quantity del y divided by del x at time the del x tend to 0. Graphically, it is shown that here this is a x-axis, this is a y-axis. Okay, so this is a x, it is a function of x, that is y of x. Okay, so it is give the graph like this. Here you are taking the slope. In this slope, if you calculate the tangent means, what is the tangent? Here that is opposite side divided by adjacent side. So that is given the values of the del y divided by del x, that is dy divided by dx at a point P. Here this is a point P. We are taking this slope means at a point P represent the tangent to the curve. At a point P. The tangent to the curve means that is give the values of the dy divided by dx. It is also equal to del y divided by del x. Check that the dy divided by dx represent the limit that quantity del y divided by del x.